Good afternoon. Today we are going to discuss very important property of definite integral. Section 7.10 of NCERT. These properties help us to integrate faster. We don't need to fully evaluate them every time. So we use the property so that we can directly find the value of definite integral. We will go through the each property one by one, understand its logic and see example. I will also tell you where and why we use this property and how it is useful to calculate the value of definite integral. Okay. So we'll list below some important properties of definite integral, and these are useful to evaluating the value of definite integral more easily. We can directly find the value of definite integral. We don't need to go through the long process. Okay. As pro- First property is, we write it as p0. We have to remember. We also have to remember the naming, that is property number is p0. Okay. So the property says the definite integral value from a to b fx dx is equal to the value of definite integral a to b ft dt. We already changed the variable here. In the first, the variable is x, and here the variable is t. So this property says that if in a definite integral, if we only change the variable, the value doesn't change, the value is same. So we can change the variable without changing the value. Okay, this is the property number 1. Property number 1 is, that is p1. Property number p1 is definite integral value from a to b fx dx is equal to minus definite integral from lower limit b to a fx dx. What this property represent? In this property, it says that we can change the upper limit and lower limit by just putting the negative sign. We write, we change the upper limit to lower limit, that is, in first, upper limit is b and lower limit is a, but when we put the negative sign, the upper limit and lower limit is reversed. Now the a is upper limit and b is lower limit. Okay. In particular, the definite integral value from a to a fx dx is 0. This is your property number 1. Property number 2 is, p2 is, the definite integral from a to b fx dx is equal to definite integral from a to c fx dx plus definite integral from c to b fx dx. This property says that we can split the interval and find the value of definite integral. Here the interval a to b is split into two parts, a to c and then c to b. So definite integral also can be split into two parts. At first we integrate from a to c, and then we add from c to b and add to get the value of definite integral from a to b fx dx. This property used in piecewise function, where the function is defined in pieces, and so we can integrate in different pieces, and when we sum, we get the value of definite integral on entire interval. For example, there is an interval from 1 to 2 and 3 to 4. So we integrate from 1 to 2 plus integration from 3 to 4. Okay. P3 is, property 3, P3 is, the value of definite integral from a to b fx dx is equal to definite integral from a to b f a plus b minus x dx. This is very important property. We use this property in mainly in symmetric function. We see how we use this property. Generally use in like sine function, cosine function. This property says that the value of definite integral from a to b fx dx is same as the value of definite integral if we substitute a plus b minus x in the function. Okay. P4 is the value of definite integral from 0 to a fx dx is equal to value of definite integral from 0 to a f a minus x dx. Same as property 3, P3. Here the value of a is 0 and b is a. So it is same as previous one. So the value of definite integral from a 0 to a f a minus x dx is same as value of definite integral from 0 to a fx. Okay. These are the 5 property of definite integral. Just remember it by P0, P1, P2, P3, P4. We use these properties to prove another property. Just like to prove P2, we use P1, P0. P5 is the value of definite integral 0 to 2a fx dx is equal to 0 to a fx dx plus definite integral from 0 to a f 2a minus x dx. Okay. So the interval now here the value of definite integral is split it into two definite integrals, and the limit is also changed. In the first, the limit is 0 to 2a, but now we have to only integrate from 0 to a. The first function is fx and second function is f 2a minus x. P6 is the value of definite integral from 0 to 2a fx dx is equal to 2 into integral 0 to a fx dx. If f2a minus x is fx, and same the value of definite integral from 0 to 2a fx dx is 0 if the function value at 2a minus x is minus fx. Okay, this is your property number 5, P5 and P6. P7 is if f is an even function. What is even function? Even function means if we take negative point, that is if we take f minus x, the value is same as fx. For example, the function x square. This is an even function because when we put in place of x minus 1 or plus 1, the value is same as 1. Like if we put 2, then the value of fx is 4, and if we put minus 2, then is again 4. So the value for f at minus x and fx is same. Then the function is called even function. And for even function, check the limit, limit of definite integral minus a to a. So now we have to integrate an even function from the limit minus a to a. So this value comes 2 from definite integral from 0 to a fx dx. Here limit are changed. Now we don't need to fully integrate from minus a to a. We just need to integrate from 0 to a and then double it. We get the value for minus a to fx dx. This is because even function is symmetric function. So when we see the graph of an even function, we can clearly see how when we double the integral from 0 to fx dx, we get the value of definite integral from minus a to a fx dx. Because the definite integral is directly related to a area function. It gives the area from the lower limit to upper limit for that function, a curve and the horizontal axis, and the lower limit and upper limit line that is parallel to y axis. Okay, so now we prove the individual property, how we can get this property. So first, P0 property is when we integrate a function a to b fx dx, we get integration a to b ft dt. We just change the variable. In first the variable is x, and in second the variable is t. So in the definite integral we can change the variable. It does not change the value of definite integral. So we can prove it. So on taking a to b fx dx, let x is equal to t, then dx is equal to dt. We apply the substitution method to prove this result. Okay. So we just take we see if we take the another variable in place of x, we take it as t. So dx is equal to, that directly differentiate to dx is equal to dt. And in the definite integral, when we apply the substitution method, we also need to change the limit according to our new variable. So now when x is equal to a, then t is equal to also a, because x is equal to t. And when x is equal to b, then t is equal to b. So limit doesn't change. And in previously limit tending to a to b varies from a to b, and now it also varies from a to b. So therefore, from definite integral from a to b fx dx is same as definite integral from a to b ft dt. So this property says that we can freely change the variable in definite integral. It does not affect the solution. This is your property P0. Okay. Now P1 is the integral, definite integral from a to b fx dx is equal to minus definite integral b to a fx dx. This property used to use this property so that we can change the limits. If we want to convert the limit as the upper limit become lower limit and lower limit become upper limit, we just put the negative sign and we change the limit. Okay. And in particular, when the limit are same, that is upper limit is equal to lower limit, the value of definite integral is 0. So if there is any question where the upper limit is same as lower limit, we don't even need to see what is the function. We directly write it as 0. Let's see how we can prove this. Okay. So to prove P1, let f be antiderivative of f. To find the value of definite integral, at first we need to find the antiderivative. What is antiderivative? Antiderivative is the value of in indefinite integral but without constant of integration. So now we apply the second fundamental theorem of calculus to find the value of definite integral. Second fundamental theorem of calculus says that if we need to calculate the value of definite integral from a to b fx dx is equal to the value of antiderivative at upper limit minus value of antiderivative at lower limit. Okay. So if we take the negative sign common, we get minus bracket antiderivative at a minus antiderivative at b. We just take the negative sign common. So now we can write it as the definite integral from a to b fx dx, its value is fb minus fa. And when we take negative sign, it becomes fa minus fb. So the role of limits are changed. Now a is upper limit and b is lower limit. We just take the negative sign common. So by using this property, we can reverse the limits of any definite integral. This is your property 1, P1. Let's say a particular case, that is when the limits are same. So if a is equal to b, that is upper limit is equal to lower limit, then the value of definite integral from a to a fx dx is equal to fa minus fa, where f is antiderivative. As here a is equal to b, so we get fa minus fa, and that is 0. So this property says that if limits are same, then that value of definite integral is 0. Okay. Now P2, property number 2. The value of definite integral from a to b fx dx is equal to the value of definite integral from a to c fx dx plus value of definite integral from c to b fx dx. So this property implies that we can split the interval. It means if we have to integrate any function, find the definite integral value from lower limit a to b, and we don't know how to do this, and we know the break is piecewise, so we just break it into two or more three parts. It's up to you how we can break the interval. For example, if you want to break into three and more part, we just take the interval from a to c and then c to b, and we can also take from a to c, then c to d, then d to c, and c to b. So that's how we can split the interval and get the value of different integral at different interval. This property is used in general in piecewise function, where the function is defined as in pieces. Okay. So now, how we can prove this? Let's consider f be an antiderivative of f, capital F be antiderivative of f. Then, by property of fundamental theorem of integral calculus, is that the value of definite integral from a to b fx dx is capital F b minus capital F a. So just calculate the left hand side. The value of definite integral from a to c fx dx is here upper limit is c, so it become capital Fc minus capital Fa. This is your equation number 2. Second term of right hand side, that is from c to b fx dx is become, here the upper limit is b and lower limit is c, so it become capital F at b minus capital F at c. This all three equations are found by the second fundamental theorem of integral calculus. Okay. So adding 2 and 3 to get the right hand side, we get from a to c fx dx plus integral from c to b fx dx is equal to fb minus fa, because fc is cancel out from equation 2 and 3 when we adding equation 2 and 3, and that from we can see from the equation 1, that is the value of definite integral from a to b fx dx. Therefore, we can split our definite integral by using this property number P2. Okay. Now, P3 is the value of definite integral from a to b fx dx is equal to the value of definite integral from a to b f a plus b minus x dx. It means when we add upper limit and lower limit and subtract x, then the value of definite integral is same as the value of definite integral from a to b fx dx is equal to value of definite integral from a to b f a plus b minus x dx. Okay, we use this property generally in symmetric function. In which function, when we write like a function like sine function, the sine x value is same as sine pi minus x. So if the limit goes from 0 to pi and we have to integrate sine x, so 0 to pi sine x dx can be also written as 0 to pi sine pi minus x dx. Okay. When we do some example, we understand how we use these properties. Okay. So if we want to prove the property 3, P3, let's consider we use the substitution method to prove this. Let's consider a new variable t is equal to a plus b minus x. Then differentiate it with respect to x, we get dt is equal to minus dx. And in second step, we have to find the new limit according to my new variable. So when x is equal to a, t is equal to just substitute the in value of t is equal to a plus b minus a cancel out, so t is equal to b. And when x is equal to b, t is equal to a. Therefore, firstly, x varies from a to b, but now t varies from b to a. So it become a to b fx dx is equal to minus b to a f a plus b minus t dt. So what is the by using property 1 p1, what is the property p1? P1 says that by taking the negative sign we can reverse the limits. So when we take negative sign, negative negative become plus, and we just reverse the limits. Now b become upper limit and a become lower limit. So we get definite integral from a to b f a plus b minus t dt by using property p1. And property p0 is what? Property p0 says that according to property p0 we can use different variable, as in place of t we just take x, and it says that the value of definite integral does not affect it. So by using p0 we get definite integral from a to b f a plus b minus x, not t, minus x dx. Okay. Now p4 is 0 to a fx dx, the value of definite integral is equal to the value of definite integral from 0 to a f a minus x dx. To prove p4, we put t is equal to a minus x, same as to we use the way to prove p3. So dt is equal to minus dx. Change the variable according to new variable. When x is equal to 0, t is equal to a, and when x is equal to a, t is equal to 0. So now limit varies from a to 0. So my integral become minus value of definite integral from a to 0 f a minus t dt. So now using p1, the limits reversed. So we get 0 to a f a minus t dt. We just take the negative sign, and negative negative become plus. And now using the property 0, we change the variable. We get 0 to a f a minus x dx. Property 5 is to integrate a function from 0 to 2a, we can split it into two parts. Now we can integrate from 0 to a fx dx plus again from 0 to a f 2a minus x dx. To prove this, now we use the property number 2 to prove this result. What is property 2? In property 2, we see we can split the integral into intervals. That is, the integral from a to b fx dx can be written as integral from a to c fx dx plus integral from c to b fx dx. So we just split the interval. In the first left hand side, the interval is from 0 to 2a. Lower limit is 0 and upper limit is 2a. But now we split the interval. At first we take from 0 to a fx dx plus integral from a to 2a fx dx. So we just split the interval. Okay, the interval is same. Here at first we integrate the definite integral from 0 to a and then from a to 2a using property p2. Now let t is equal to 2a minus x in the second integral on the right hand side. Then dt is equal to minus dx. We just differentiate with respect to x. So when change the limits. So when x is equal to a, t is equal to a, and when x is equal to 2a, t is equal to 0. and x is equal to 2a minus t. Therefore, the second integral become a to 2a fx dx is equal to minus a to 0 f 2a minus t dt. So at first apply the property p0, we get 0 to a f 2a minus t dt. We just uh, reverse the limits, so we get negative sign and negative become positive, and then change the variable, we get 0 to a f 2a minus x dx. Hence we get the result, that is we can split the interval and we don't need to find the definite integral from 0 to 2a. Now we split into two parts and we just need to calculate the definite integral value of two functions, first one fx and f2a minus x from 0 to a. Now property 6 is we can write the value of definite integral from 0 to 2a fx dx is 2 into integral from 0 to a fx dx if f2a minus x is fx and 0 to 2a fx dx is 0 if f2a minus x is equal to minus fx. So let's suppose there is a function function, and if it satisfies the property that if we put 2a minus x in place of x we get minus fx, then we don't need to find the value of definite integral if the limit is 0 to 2a. We just write it as 0 by using property 6. Let's prove it. Using P5 previous property, we can write 0 to 2a fx dx as 0 to a fx dx plus 0 to a f 2a minus x dx. Okay, we just use the property 5. Now, if f2a minus x is fx, then 1 become 0 to 2a fx dx is equal to 0 to a fx dx, and in place of f2a minus x we just put fx, so we get 0 to a fx dx. So both are same, so we just add in, we get 2 into 0 to a integration 0 to a fx dx. And if f2a minus x is minus fx, then 1 become 0 to a fx dx minus integration 0 to a fx dx. Both cancel out and it become 0. Okay. Now P7 is if f is an even function. I already give you example of even function as x square. So if f minus x is equal to fx, then just see the clearly what is your limit. Limit is minus a to a fx dx. If you want to apply any specific property of definite integral, we have to see what is the limit. The limit also same as the property. So if you apply the property of even function, the limit must goes from minus a to a. Then fx dx is equal to 2 into 0 to a fx dx. So now, from now, if you want to calculate a value of even function, integral value of definite integral value of even function, we don't need to calculate from minus a to a. We just calculate from 0 to a fx dx and double it to get the value of definite integral from minus a to a fx dx. And if f is an odd function, that is f minus x is equal to minus fx, for example x cube, so x cube is an odd function. So in that case, if we want to find the value of definite integral from minus a to fx dx, it is 0. We don't even need to calculate the value of definite integral, we get it as 0. Let's see why. So using P2, the property P2 is splitting property, that is we can split the intervals. So at first we split it as minus a to 0 and then 0 to a. So over interval is minus a to a, and we write as minus a to fx dx plus 0 to a fx dx. So let t is equal to minus x in the first interval on the right hand side. So dt is equal to minus dx. So when x is equal to minus a, t is equal to a, and when x is equal to 0, t is equal to 0. Also, x is equal to minus t. So just substitute, we get minus a to a fx dx as minus a to 0 f, in place of x we substitute minus t dt. Now we use the property 0, change the variable t to x, 0 to a f minus x dx plus 0 to a fx dx. Now if is an even function, then f minus x is equal to fx. So equation 1 become, in place of f minus x we just substitute fx. So we get 0 to fx dx plus again 0 to fx dx. So we get 2 into 0 to a fx dx. Therefore, for an even function, if you want to calculate the value definite integral from minus a to fx dx, we get 2 into 0 to a fx dx. And if f is an odd function, then f minus x is equal to minus fx. So it become 0 to a minus fx dx plus 0 to a fx dx. Both cancel out and it become 0. Therefore, for odd function, the value is 0. So there are all 10 property, and now we use this 10 property to find the value of definite integral. Sorry, 7 property. So the first question is, we have to find the value of definite integral from minus 1 to 2 absolute value x cube minus x dx. Now we need to calculate the value of definite integral. How we can calculate this? Just think. So when we figure out x cube minus x is positive or negative, firstly we have to figure out in which interval the x cube minus x is positive or negative. We cannot directly integrate the absolute sign. We have to remove the absolute sign, and when we remove the absolute sign, it either positive or negative. Okay, so we have to figure out in which interval the x cube minus x is positive or negative, and the whole interval is, we have to integrate from minus 1 to 2. So to do this, we find where the interval is 0. So we have to find the value of roots. So just simplify it. X cube minus x is equal to 0. Let's take x common, so it become x into x square minus 1 0. Apply the formula of a square minus b square, it become x into x minus 1 into x plus 1. So either x equal to 0 or x minus 1 equal to 0 or x plus 1 equal to 0. So we get the curve crosses through cross the x axis at x is equal to minus 1, x equal to 0 and x equal to 1. From wherever the curve crosses the x axis, that is x is equal to minus 1, x equal to 0 and x is equal to 1. So now let's take some values in between these points to see if x cube minus x is positive or negative. This is the way how we can figure out any function is positive or negative in which interval. At first we find the value of roots, and that point suggests from where it cuts the x axis. So when we get the root, that is 0, 1 and minus 1, it suggests the curve cross the x axis at minus 1, 0 and 1. And to change the sign of any curve from positive to negative or negative to positive, it must cross the x axis. If we can imagine in graph, so that if a function is positive and it want to become negative, it must cross the x axis. So at first we have to find the points from where at which the function crosses the x-axis, and then we see in which interval the function is positive and the function is negative. So according to this roots, now my interval is break into three parts. First, -1 to 0, okay, then 0 to 1, and 1 to 2, as function crosses at -1, 0, and 1. So between x to -1 to 0, we just take an point from -1 to 0. Let's suppose we take it as -0.5, and we substitute at the function, that is x cube minus x, we get -0.5 whole cube minus 0.5. So when we simplify, we get 0.375. That is positive. So just imagine in graph, we take a point from -1 to 0, a middle, any point from, let's for example, we take -0.5, and at -0.5 the function give the positive. So at this range from -1 to 0, the function is positive. Okay, and in the entire interval the function is positive, because to change the sign of that function, it must need to cross the x-axis, and it only cross the x-axis at -1, 0, and 1, and we check at the interval -1 to 0. So on -1 to 0, we can remove the absolute sign, we get x cube minus x, because at this interval the function is positive. Now between 0 to 1, on the interval 0 to 1, let's take an example 0.5. You can take any example, any point on the interval 0 to 1. You can take 0.3, 0.2, any point, and we just check the sign at that point. So when we calculate x cube minus x, we get 0.5 whole cube minus 0.5, that is 0.125 minus 0.5, that is minus 0.375, and that is negative. So at this interval, the function is negative. So when we remove the absolute sign on the interval from 0 to 1, we get minus x cube minus x. Okay. Now between x 1 to 2, 1 is also another point of where the function cross the x-axis. So we just take any point from 1 to 2, we take 1.5, and when we calculate the value of that function at point 1.5, we get 3.375 minus 1.5, that is 1.875, and that is positive. So at this interval, the function is positive. So we can remove the absolute sign and we get it as x cube minus x. So we break the interval into three parts, from -1 to 0, then 0 to 1, and then 1 to 2. And we see where when we remove the absolute sign, we have to remove the absolute sign to integrate it. So at first interval, it is positive, so x cube minus x. In second interval is negative, so minus x cube minus x. And the last interval, it is again positive, so x cube minus x. Okay. Therefore, this is greater than 0 on interval -1 to 0, less than 0 on 0 to 1, and again greater than 0 on 1 to 2. So now apply the property P2, and P2 says when we have to integrate from a to b fx dx, we can split the interval, and here we need to split the interval because the value of absolute function x cube minus x is different on intervals. It is different in -1 to 0, and then it is different from 0 to 1, and then again is different from 1 to 2. So we need to split into intervals so that we can find the value of definite integral. So by using this property, we split the interval of -1 to 2 into first -1 to 0, then 0 to 1, and then 1 to 2 by using property P2. And we write the value of x cube, absolute x cube minus x, as it is positive or negative on that interval. At first interval, it is positive, so we take it as x cube minus x dx. In the second interval, 0 to 1, it is negative, so we take minus x cube minus x dx. And the last interval, it is again positive, so we take x cube minus x dx. Okay, so just simplify it. So we apply the standard integral property, that is integration of xn is x the power n plus 1 by n plus 1. So when we apply this property, the integration of x cube is x4 by 4. Integration of x is x square minus 2. So we get minus. Till now we just do a indifferent integral. And we write the upper and lower limit in the square bracket corner. In the upper corner there is a upper value of upper limit, and the lower corner there is a value of lower limit. And when we find the value of antiderivative, now we apply the second fundamental theorem of integral calculus. We just substitute the value of upper limit and then lower limit and subtract it. So at 0, it is 0. So we don't need to put it. And when we substitute minus 1, it becomes minus 1 by 4 minus 1 by 2. Plus at 1, it is 1 by 2 minus 1 by 4. And at 0, it is 0. Plus for the third part, we get 4 minus 2 when we substitute 2, because and then minus fa, that is f1. So 1 by 4 minus 1 by 2. When we simplify, we get 11 by 4. And that is the value of definite integral. Okay, so in this integral we have to divide into the intervals. We cannot directly find the value of definite integral, because the function, that is fx, that is absolute with absolute sign, and the value of absolute sign is changed over the intervals according to it is positive or negative. So at first we change, we see where the interval function is positive or negative, and according to that we split the interval into three parts, and then we find the value of definite integral. Okay, now the example number 29 is find the value of definite integral from minus pi by 4 to pi by 4 sine square x dx. Okay, so we observe that fx is equal to sine square x is an even function, because when we take minus x, f in minus x, we get fx. So when we have to check it is an even function or odd function, to apply the property of even and odd function, we have to see the limit of upper and lower limit. That is, the limit is minus a to a. So if there is a limit like this, that is a minus a to a, so here a is pi by 4 and minus a, that is minus pi by 4 to pi by 4. So we can apply the property of even function, odd function. So we can check, we check the function fx is an even function or an odd function. So if it is an even function or odd function, we directly apply the property of definite integral. Okay, and as here we see the sine square x in even function, we apply this property that the value of definite integral from minus a to a fx dx is equal to 2 into the value of definite integral from 0 to a fx dx. So to integrate a function sine square x dx from minus pi by 4 to pi by 4 as sine square x an even function, we don't need to integrate from minus pi by 4 to pi by 4. Just find the value of definite integral from 0 to pi by 4 and multiply with 2 to get the value of minus pi by 4 to pi by 4. Okay. So now we don't know the integration of sine square. So we use the trigonometric identities that we can write sine square x as 1 minus cos 2x by 2. And because we know the integration of cos 2x, We don't know the integration of sine square x. So we replace with 1 minus cos 2x by 2. When we simplify, we get 0 to pi by 4, 1 minus cos 2x dx. So at first we find the value of antiderivative. So integration of 1 is x, and integration of cos 2x is the standard formula of integration of cos ax is sine ax by a. Here the value of a is 2, so we get sine 2x by 2. Now we apply the second fundamental theorem of integral calculus. At first put the upper limit value, that is pi by 4 minus 1 by 2 sine 2 into pi by 4, that is pi by 2 minus 0, because sine 0 is 0. So we get pi by 4 minus 1 by 2, because sine pi by 2 is 1, and that is the value of definite integral, pi by 4 minus 1 by 2. So in this question, we just see that the limit is minus pi by 4 to pi by 4. So it click in mind that we can maybe we can use the property of even and odd function. So we check the function is even function or odd function, and if its function is even function, we apply the property of even function, and if it is an odd function, then property says that the value of definite integral is 0. Okay. Now next example is find the value of 0 to pi x sin x by 1 plus cos square x dx. Let's consider it as I is equal to the value of definite integral from 0 to pi x sin x by 1 plus cos square x dx. Now we use property number 4, that is 0 to a fx dx is equal to 0 to a f a minus x dx. Generally you use this property on symmetric function like in trigonometric function, sine function, cos function. So in this type of function we use the property p4, that is 0 to a fx dx is 0 to a f a minus x dx. Okay. So we get I is equal to 0 to pi minus x sine pi minus x dx by 1 plus cos square x dx. So if we use this property, then after substituting a minus x, it is similar or it is identical to the function, that original function. As we can see here, it become pi minus x into sine x dx by 1 plus cos square x, because sine pi minus x is sine x. So in this type of function, you use the property 4. So it become pi into 0 to pi integration sin x dx by 1 plus cos square x minus 0 to pi x sin x by 1 plus cos square x dx. And that is identical to the question. So we can substitute it as I. So we get 2i is equal to pi from 0 to pi sin x dx by 1 plus cos square x. So when we simplify, now we just calculate the value of integral from 0 to pi sin x dx by 1 plus cos square x dx. Okay. So we use the property of substitution. We just take it as cos x is equal to t, because when we differentiate, we get minus sin x dx. That is a constant multiplication of numerator. Change the limit. When limit x is equal to 0, t is equal to 1, and when x is equal to pi, t is equal to minus 1. So it become I is equal to minus pi by 2 from 1 to minus 1 dt by 1 plus t square. Now use the property p1, that is we can reverse the limit by taking the negative sign. So we take negative, and negative negative become positive, so it become pi by 2 from integration from -1 to 1 dt by 1 plus t square. And since we say the limit from -1 to 1, that is minus a to a, so we can use the property of even function, an odd function, and as 1 plus 1 plus 1 by 1 plus t square is an even function. How we can say it is even or not? Just take it as f t is equal to 1 by 1 plus t square and put f minus t. So when we replace by minus t, so 1 by 1 plus minus t whole square. So again it become 1 by 1 plus t square. So given function is even function. So we apply the property even function. So now my integral become 2 into from 0 to 1 dt by 1 plus t square. 2 cancel out, as the integration of 1 by 1 plus t square is tan inverse t. So we get pi into tan inverse t, lower limit 0 and upper limit is 1. Just apply the Sanket fundamental theorem of integral calculus and we get the value. The value of tan inverse 1 is pi by 4 and tan inverse 0 is 0. So when we simplify, we get pi square by 4. The final answer is pi square 4. Okay. So in today's class, we see how we use the specific property of definite integral to calculate the value of definite integral.